numbers, I will distribute first. X to negative 1/3 times x is x to negative 1/3 plus 1, which is 2/3, and minus 2, x to negative 1/3. I'm not afraid of the product rule, but why, when this is much easier? So then I find h prime of x, which is 2/3, x to 2/3 minus 1, which is negative 1/3, and then plus 2/3, and x to negative 1/3 minus 1, which is negative 4/3. Now the trick here is mandatory, a clean ship, as I said, a friend of mine says that. So I have to factor out 2/3 and x to the smaller of these two powers. Which is the smallest of the two powers? Very good. So from negative 1/3, when I subtract negative 4/3, what do I get? X to which power? Anyone?
3/3, so 1.
Very good indeed. So it's x and then plus 1. I already took the 2/3 outside. Plus 1. Very good. So h prime is nothing else but 2/3 x plus 1 over, if you want, the cube root of x to the 4th. So now when it comes to critical numbers, they come from two sources. From f prime being undefined, if any, or from, or and I should say, both can happen, f prime being 0. Can anyone give us the f prime being 0? Very good, awesome. Indeed, a fraction is 0 only when the top is 0, so that's how we get negative 1. Perfect. Can anyone give us the other option of undefined?
When x is 0.
Very good. However, this function is not defined when x is 0, because this is basically x minus 2 over the cube root of x. So this is not a critical number. It is indeed, the first derivative is undefined at 0, but so does the function, or so is the function. So x is not a point of the function, so the only critical number is negative 1. X equals 0, the function is undefined, so it cannot be a critical number. Good. Anything else? Other questions, or can we move on? Okay, so moving on, we'll continue with 4.2. The reason why I didn't study the sign here is because it wasn't asking us to find max min. But let's continue and study the sign as if it's asking us, okay, you found the critical numbers. You found one. So now tell me whether this turns into a max or a min. It doesn't have to. So let's do that. So we have x. I know the function is defined everywhere except at 0. So this is our h prime. And this is our h of x. So nothing is defined at 0. And then I have to put in negative 1. And when I put in negative 1, I get 0 here. I have to study the sign of the derivative, but I will not study the sign of all this, because this is positive. So I'm not going to worry about that piece for studying the sign. Who cares? It's all positive. So before negative 1, that would be negative. And after negative 1, the whole thing is positive. How do I know? Just plug in numbers, or think in terms of a linear function. It comes from negative, it crosses at -1, and it goes positive. Or plug in numbers. At this point, I have to plug in -1 and get this value. So when I do that, -1 here is -1. -1 minus 2 is -3 over -1. This is 3. Now, to make sure that everything is working well, when I determine the limit at -infinity, this is too small to mention. But this is the cube root of x squared. And the cube root of x squared is always positive. So infinity and infinity. I should determine these limits, left and right, of 0. And if I do that, the numerator is always negative, and the denominator on the left is negative. On the right is positive. So this must be positive infinity and negative infinity. Now this is the moment of truth. This is when I check whether all my work so far is okay, free of mistakes. So, from infinity to 3, the function is decreasing. Is that supported by the first derivative? The answer is yes. From 3 to infinity, obviously the function is increasing. Is that supported by the first derivative? Yes. From -infinity to infinity, the function is increasing. Is that supported by the sign of the derivative, of the first derivative? Yes. This is a typical situation for what? Negative slope, 0 slope, positive slope. So what type of point is -1, 3, and it means that the critical number turned into a max min? Which one? Very good. Local minimum, also called relative minimum, same thing, whatever you want. So local or relative, they mean the same thing. So this critical number turned into a max min, specifically into a min. And that's basically half of this chapter. If you understand that, you understood half of the chapter, chapter 4. Okay, let's look at 4.2. We're going to look at 2 theorems. One is called Rolle's theorem, and the other one, the mean value theorem. So let's start with Rolle's theorem. So let's look at the following situation. And this all comes from what we discussed so far. Let's suppose I have a function that starts here at A and ends here at B and does whatever you want in between, and it's continuous. It can do just this, it can do just this, or this, or it can do this. Doesn't matter. But it starts and ends at the same y value. So f of A equals f of B by construction. It doesn't have to do all this. It can just go simply in one shot, either from above or from below, or can do as many times as you want, till here. So the hypothesis of the theorem, number 1, f continuous on the closed interval a comma b. Would you agree with that?
Yeah.
Number 2, f differentiable on at least the open interval a comma b. Nobody cares if it's differentiable at this point and this point. It may be, that's fine. But the requirement is that at least it's differentiable anywhere in between. It can be not differentiable at the endpoints. Nobody cares. And step number 3, f of A equals f of B. I should say the third hypothesis. Then, by Rolle's theorem, there exists a C in the open interval A comma B such that what do you think? So there exists at least one C in the open interval such that, what do you think? Give it a shot. You already have the hint right here. Is it my computer or I cannot hear you?
I can hear you.
So what was it, 10? I plugged in my device and my camera went off. And now my mouse is not working. I know. And I'm using a mouse because my device is so far away from me. Okay. Such that what? F prime of C is 0. In other words, it's guaranteed at least one turn. Guaranteed at least one turn. In other words, max min. That's what we mean by a turn. So if all these happen, there must be at least one turn. Guaranteed.